And instead of have to handcraft every rule, handcraft every probability in the old AI system, we want the AI to learn, to adapt to how the players are consuming it.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Joining me today on How AI Happens is the head of data, AI, security, and IT over at Second Dinner Studios, Xiaoyang. Xiaoyang, welcome to the podcast. How are you today?
I'm doing great. Thank you, Rob, for having me here.
So pleased to have you. Lots to get into in terms of the AI and ML being injected into video game development, which is what Second Dinner primarily concerns itself with. First, though, congratulations are in order. Congrats on launching Marvel Snap, your most recent game that is in the Marvel universe. So congrats on getting that out the door.
Thank you. Thank you. We recently just announced it. Right now, we are getting players' feedback with our soft launch in a few countries. Really great feedback and awesome things our players are consuming our game. So really glad. And thank you, Rob.
The video game launch is an interesting one because it's related to this constant problem I come up against when I'm speaking with folks, which is, how do you know when the product is good enough to move from testing to production? And in some cases, I feel like you can't ever traverse that final gap until it's out there in the world. And now I'm sure you're getting all this user feedback, things you didn't think of. Is that the case?
Yeah, that's a great question. So we think this quite a lot. And different games and different game studios have very different philosophy. You probably have heard one end of the spectrum, people talk about, hey, it's very much data-driven approach so that we define certain type of KPIs. And if we hit them, okay, ready to go to the next milestone. So the other end of the spectrum very often is more kind of creative and design-driven. So my gut feeling tells me as a game designer, I think this is good enough. I feel my players are happy enough. Time to go to the next gate, to go through the next milestone. So that's a pretty wide spectrum. And in between, there are a lot of different ways to do it and think about it. I think our philosophy is, instead of thinking about, hey, is data driven or gut feeling driven, we try to really listen to what our players are saying. So one way to do it is through data, not surprisingly. We use data as a tool instead of saying, hey, data is driving our decisions. We use data as a tool to really listen to what our players are saying, how they're using our product, what's their pain point, what's their joys and everything. And then we translate their voices using data into insights so that we can make informed decisions to see if we're ready to go to the next step and what are the iterations and improvement we need to do over there. And sometimes it means big changes, right? So we're not shy away from making big changes because we want to launch a game. It's a live service game that players will be enjoying for many, many years. And a lot of players will enjoy it. So we want to make sure that we constantly and keep iterating on the game. And even if it means there's a huge change that needs to be made to the game.
Yeah, of course. Is some of the insight you glean because of the scale you suddenly realize when you go from however many testers that have been working on it to all of these players, thousands, hundreds of thousands, hopefully millions, now all in the game at the same time? Is the scale part of the equation there too?
Absolutely. That's a really great point. Traditional game development usually start with prototyping and a very small limited scale of playtests. And there is a limitation to that. There is a huge value from that because you can get really fast iteration, get a lot of feedback from those players. The limitation over there is they're very selected type of players. And very often they're folks who are like extremely excited about this genre and who has tons of experience in this genre. And when you go out to a mass audience and you usually realize, hey, actually there are a lot of different types of players. There are players who is like super hardcore into the genre. There are players who are very interested. And there are players who are just super new. They've never tried this before, but they could be a potential opportunity for this product. So when you really go out and you realize the player's sentiment, their motivation, and their fantasy for the game, it's a big spectrum over there. So when you see the scale, you actually start to understand that different players have different desire. Sometimes different players see the same feature or the same type of experience in a very different way. Some people could be very passionate about some really hardcore competitive features. And some casual players are like, that's too much. It's too much for me. I don't think that's something I would encourage a game developer to focus on for now, because I want something that's for me. That's a really great point, Rob. I think when we hit the scale, and now we're seeing it, we see more players coming in, not just hardcore players, but more kind of other players, more casual, mid-core, and opportunity-based players coming in. So we're really listening to, hey, what all of these players are talking to, and data plays a great role over there, because it's no longer scalable to talk to everyone and just sit down and watch how everyone is playing.
Yeah, of course. So we sort of jumped in at the deep end here with video game shipping and receiving user feedback. I want to get into more of that as we go along. But first, I'd love to just introduce you to the folks out there in podcast land, because you have had this career in video games, working at Blizzard and then Riot Games. And I'm just curious if you could walk us through your career a little bit, maybe share with us how you came to Second Dinner Studios, and then at what point in your career AI and ML started to play a factor.
Yeah, so I came from a background that is a little bit interesting to start with. So my undergraduate major was in theoretical physics, which probably has nothing to do with video games and has limited connection with machine learning and AI. It's a very theoretical, mathematical subfield of physics. So when I was doing my undergrad, because I went to a very small college and with a close connection with some of the national labs doing physics research, I started doing some research in the particle physics space, and which for folks who are familiar with this actually involves huge amount of data. It's pretty much like, at least back in the days, you can't actually observe what's actually happening there in the particles, and you need to interpret what's happening by getting a lot of data and do modeling and understand what's happening deep down there in the very microscope. So I did a bunch of work over there, and it was a very fun opportunity. I went to a lecture. The lecture was given by a professor who is doing vision research. And the professor was from a physics background, and he started talking about how the mindset and numerical computing and the modeling that is derived from a lot of more fundamental physics space are widely used in the space of computer vision and vision research in general. That was super inspiring to me. So after the lecture, I went to talk with the professor, and I was like, hey, I have no idea what I can do in the vision space. I'm a theoretical physics major. Some of the topics you mentioned, you just talk about, is super interesting, and I feel I want to learn more. And he was like, oh, come to my lab, do some research here. And I think physics major is great. Just come over here and have a try. So I went there, did some research, and we started doing some like the early days machine learning AI stuff, it's machine learning modeling to understand the vision perception. And it's very fun there. And we happen to know a professor from a graduate school from UCLA, actually, was doing research in a very similar space and collaborating with that professor in my undergrad school. So I ended up talking to that professor as well. We started working together also with my professor in the college on some vision and machine learning projects. And then I ended up going to the grad school doing machine learning and vision research. So that opens the door for me thinking about how to use my background in mathematics, theoretical physics, and modeling to help understanding how the human vision works. What are the assumptions? What are the optimizations that our human visual system is doing? By the way, our visual system is fascinating. It's probably one of the most powerful systems that you can imagine, like in any of the things we have built and experienced. It's just fascinating there. At that point, my focus was pretty much on machine learning, and theoretical part and modeling part of the vision. I have no idea that you can do anything with this background in gaming. So it was very fun. I realized one day, hey, Blizzard is actually in California. The headquarters is there. I've been playing the game for many, many, many years. So I applied for some random positions over there. I just like search keywords and saying, hey, what are these things? What are those things? I applied for those. First year, I didn't even get a rejection letter. Second year, I got a rejection letter, which I'm like, oh, that's progress. That's awesome.
Progress.
Someone's reading my resume. So year 3, the head of, back in the days, they call it business intelligence, the head of essentially the data department over there, gave me a call and said, hey, your background seems interesting, where there are some fun things we're trying to do over here. You probably can help us. So I got an internship at Blizzard. So that opens the door to go into game industry. So when I walk into Blizzard, I have no idea actually what I can do there. So I'm like, it's Blizzard, I'm going to do it. So I went there. I started working on some projects that's related to BattleNet, related to security. And eventually they gave me a full-time offer. And eventually I also moved into the game side of the game studio at Blizzard, primarily working on World of Warcraft. It's really fascinating. It was my first time actually seeing how massive amount of data is generated in this virtual world. It's literally a word, right? It's World of Warcraft. And there is so much information about player behavior. There's so much information about player motivation, what they like, what they don't like, how they interact with each other. It's a whole new universe to me. So it's just got me like so excited. And I started doing like more fun stuff in the machine learning and data space with World of Warcraft. Eventually, I got an opportunity to join Riot Games, when Riot Games is growing League of Legends, and started to think about how to make multiple games. So I was very fortunate to be part of that journey and going there and start building the data organization as Riot Games is growing. So about 2 years ago, got this amazing opportunity working with some of the old friends and colleagues in this new game studio called Second Dinner. We're very grateful we have this partnership with Marvel. So we're making this Marvel Snap as our next game. So yeah, and we see a lot of opportunities to use technology, data, AI to make the game really approachable to a wide audience of players. And hopefully some players who probably never tried the genre of collectible card games. And yeah, that's where we are. And we announced the game, launching the game. Now we're iterating on that. So it's kind of like how my journey coming from a theoretical physics major working on particle physics stuff all the way to in gaming, making some fun data and AI works here.
Yeah, thank you for setting that context. And you mentioned something really interesting related to World of Warcraft, which was just the sheer scope of data there was. And of course, if you're going to collect data in the physical world, you need sensors everywhere. But in a digital video game world, sensors are kind of everywhere. They just sort of like are in the ether of the world, no matter what. And so you capture every single action, every single equipment change, every single step, every motion, every jump, every bullet fired by a gun in or whatever item in the game. It's a huge amount. It's almost like, is it too much? Like, how do you even separate the signal from the noise when you've captured data on every single possible thing you can have data for?
So that's a really great question, Rob. So talking about collecting data from the game industry also are going through quite a bit of iteration. What's the best way to do it? So back in the days, World of Warcraft, when I was working on that, there is a combination of, hey, let's just get data from whatever operational system that is supporting the game operating, right? So if there is a record in the operational database, we replicate the record and then we interpret what it means. The awesome thing is, Rob, you just mentioned, hey, we pretty much can capture everything because in order to do anything, the backend, the system needs to know what you're doing and what you have been done in the past. The tricky part is those systems are not designed for analytics or AI. So sometimes you end up, this operational database, like how do I actually make sense of the information over there? It's so tricky. So the next iteration of a lot of the game data collection starts to add in telemetry hooks or analytics hooks in specific events or specific actions that players are doing. So this is a much more intentional way of collecting data. And the data you collected are much more ready for consumption in the purpose of AI or analytics. So we always see a combination of those. I think the industry is moving more and more towards, hey, be very intentional, add in the analytics hooks at specific places and actions so that you get really high quality and usable data from the game instead of relying heavily on the operational database. So back to your question, Rob, there are a huge amount of data, no matter which way you go, collecting the data. One of the shooting game I worked on in the past, you can, to a point, can collect every single bullet coming out of the weapons. It's a huge amount of data. And in some games, we can basically track the location of the character, the player's character on the map, and with high granularity. So a huge amount of data. And a lot of those data probably won't be relevant to some of the questions we're trying to answer. And a lot of the data could even generate certain type of noise. Just imagine if you record an intersection of a traffic light intersection for 2 months, and now you want to find some pattern about who's walking by, like what are they doing over there, by just watching all of those videos. It's probably impossible. It's really hard to do that. So there is indeed an issue of too much data, both from like a signal to noise ratio perspective, as well as from another big perspective, which is collecting data costs money. So it is an investment. Processing, storing the data, actually, it could be very expensive if you actually start doing that. So what we're trying to do when we think about too much amount of data is, I think, many of the games I worked on and a lot of the friends and connections I've been talking to regarding collecting data is we're becoming more and more intentional. We're more and more thinking about how we're going to be using the data to start, and then start being very intentional in collecting the right amount of data, and then use the data for what we need. Instead of saying, hey, let's collect everything, and then let's figure out if we're going to be using it. I think that's also kind of a evolution of how we think about collecting data and using data in gaming.
Yeah, it's important to call out how much noise there is. In the example of the intersection, say between like 1 a.m. and 4 a.m., there's largely nothing happening, right? And so you're like, oh, more data is better, but a huge chunk of that data is just not really relevant to what you need. So prioritizing feels really important. Is that what is meant by the telemetry hook you mentioned? Is that like, okay, we are going to hone in on only specific actions and only collect data on these specific areas?
Yeah, absolutely. That's the purpose. We want to be very, very intentional about what are the actions that will help us to best understand the player behavior and motivation, and what information will best represent how the players are interacting with our game. So we go through this design process and essentially design those telemetry events and flesh out what type of information and what granularity is going to be most helpful for us to answer those questions. And then we go in and design those telemetry hooks and then harvest those information to help us understanding those questions we have. I think one beauty about working in gaming data is, I think compared to some of potentially, e-commerce or advertisement companies, we can get a lot of information and we don't necessarily need to know who you are. So we don't have to collect kind of for most of the use cases regarding helping game design, game iteration. We don't really need to know if this data is from Xiaoyang or from Rob or from whoever. So what we really want to understand is the type of players and what are the behaviors and what are the motivations. And then we can iterate our product and improve our product for those type of players. So I think that gives us a lot of great opportunity to really respect the privacy of our players. We don't need to know who you are. We don't need to collect any of the personal information. We get your behavior. We know it's player, whatever, ABCD, hash number, whatever thing over there. And then we can have the analysis and we can build machine learning and data science AI models to understand what it means when this player does this behavior and what this motivation over there. So I think that is a really fun part of working with game data.
Yeah, you don't have the challenge of PII, right? Like I'm not particularly concerned what you do with the data of how my avatar runs around a Call of Duty map, you know? It's just, it's not identifiable to me. I risk nothing by letting you have that. Yeah, that's a nice little advantage. And yep. I like that you mentioned you have been deliberate about what are the player behaviors that will be illuminating for you in making the game better. And for someone who maybe believes data is like an arms race, that more is always better, we'll sort it out later, we'll figure out what to do with it, like let's just get our hands on as much as possible, record as much as possible. I would love to hear what those behaviors are. Like I'm imagining you and your team sort of sitting around a whiteboard and just writing down, okay, what do we care about? What do we care about learning from this data, and what are the behaviors associated with that? Could you maybe give some examples of what those things are?
Yeah, absolutely. I can give you one example about the genre. We're building a collectible card game, and I work on some collectible card game in the past. One of the really helpful way that you can use data in this type of game is balancing the game. So we want to make sure that the game has a pretty diverse meta instead of, hey, there's just this one way of this several cards you can use to win the game. We want to make sure that there are different sets of cards you can use to still have fun, to still be competitive in the game. That's not an easy task. In order to do that, we need to really understand what the meta looks like, how the balance look like. Especially card games usually release new cards pretty frequently. So each new release means a potential change in the meta and a potential change in the balance. So when we think about that, we start to think about, okay, in order to understand that, what type of information we want to collect? And there are definitely information about, hey, we should be collecting winning and losing. And that is basically indicating the strength of the cards and deck. And we can go deeper there, right? You can go deeper than, hey, this type of cards or this sets of cards tend to be stronger earlier game or mid game or tend to dominate at the end game. There's a lot of strength related matrix we can add to help the designers, to help the game team to understand the balance of the game. And there's another part, which is, are they fun? And a card or set has a super powerful, not necessarily means it's fun to play. Sometimes they're connected very much, but sometimes we do see a wide range of players. They choose cards and decks or sets of cards that are not necessarily the strongest. They still play it. So we also want to start looking into, okay, what are the cards and sets of cards the players are building or collecting, using, the frequency, and things like that. So a lot of metrics on that front as well. So just take this as an example. If there are very specific questions about the balance, the meta, and we can be very intentional about what type of data we want to collect. There are definitely a lot of other information we can collect. For example, we can say, hey, we can just collect every time when you start building a set of cards, how often you click on certain things, how often you use some cards, you can save it or favorite it. Sometimes it's not relevant to the questions we want to answer over here. So probably we want to make some trade-offs and get the data that provides the most signal instead of just collecting everything.
Right. And so that is under the North Star of, is it fun, right? Because is it balanced? You don't want anything to be too overpowered. You want people to be able to remain competitive, which makes it more fun. And then like, oh, this isn't the best card, but people like it because it's fun. I'm just pointing out, like, from like a product development standpoint, what are the drivers that you care about? It seems like it's important to figure out, okay, we want this to be really fun. Therefore, let's put in these telemetry hooks so that we can tweak the game in ways that make it more fun, right? So just as that is the priority, thus that is the data we're going to pay attention to.
Yep, absolutely, absolutely. I would say the ultimate goal of making a game is make it really fun for the players. And making it competitive, making it fair and balanced is a way and one of the very important pillar to make some PvP and competitive games fun. But at the end of the day, it's about making it really fun for the players to play.
Yeah, of course. So the other thing I really wanted to get into with you was this sort of explosion of possible use cases and opportunities that just result from adding AI and ML to video games. When you think about the use of synthetic data, the industrial metaverse, and what can kind of be gleaned from a simulation, really, how do you see video game development fitting into the bigger picture of maybe more widespread AI use cases?
Yeah, that's a really great question, Rob. And I think if we look back a few years, the moment AlphaGo shocked the world, AlphaGo also shocked the gaming industry. It's a very interesting coincidence. Move 37, when Li Shidong was playing AlphaGo, I think that was such a profound moment when Li Shidong himself and some of the folks in the Go community realized, I think that's creativity. The AI is doing something so innovative. I think that can be informative and helping how we humans think about problem solving and think about many, many things. It's actually very interesting, I think, for the audience, if they are fighting game fans, Move 37 is also a profound moment when there was back in the days, people realized how powerful humans are. There's some mechanics that fighting game was never designed for, humans can do it. So I think it's such a fun coincidence. Move 37 is a great example there. So back to AlphaGo, and I think that moment shocked game industry because we start to see a lot of opportunities. We can bring in AI and help facilitate creativity in gaming. Let me just go back to one of the examples we just mentioned, helping the balancing design and helping to understand if the game is fun. Thinking about how we do balance in the past. Whenever there is a PvP game, no matter it's first-person shooting or card game or MOBA, how you do balancing is the designers, they think about, okay, I think this is balanced. This new characters, new weapons, new champion, new card should be balanced. Let's give it to the players so they can help us to test. And then we observe, okay, is this indeed balanced or is this actually off? So every time you do that, it's a long process. And it also means you deliver suboptimal experience to the players. They're essentially helping you to test out. Sometimes they got pissed off. Why is this thing so OP? Why this card is so broken? Why this weapon is just not usable? So there are a suboptimal experience. There are trade-offs over there. The moment about AlphaGo, and when we start thinking about gaming, we realize, hey, AI, they can play games in a very competitive level. They can play games just very similar to how humans are going to be approaching it. And they can even play games. You can make them play games at different levels. When you start thinking about that, you realize, hey, wait a minute. What if we ask the AI to help us and tell us if the game is balanced before we give the game to the players? So the AI can play the game. We can ask the AI, hey, play like a esports competitive player, play like a hardcore player, play like a mid-core player, play like a casual player, and then go play. Millions of AI bots will be playing the game overnight. And next morning, the designer come back to his desk or her desk. They will see the balance report over there generated by the AI. That's such a powerful tool for the designers. That's such a powerful tool for game development when you start thinking about balance and meta and everything like that. So we start thinking about, hey, if AI can do and play games like that at the human level, it unlocks a lot of opportunities for us. And if you think more about it, when AI can really play at a competitive level and at different levels, that opens a new door about the PvE game. That opens a new door about how the NPCs could be interacting with the players to provide really engaging experience. So in the past, the NPC, the AI, you talk about game AI versus AI, actually very different, right? You talk about game AI, you talk about behavior tree, finite state machine, the goal-oriented action planning, like those type of traditional game AI methods that are widely used. They're not necessarily AIs that are learned from experience. They're not necessarily AIs that are kind of improving as you get more experience. And now we think about, wow, AI can learn to such a level. And there's new research coming out that means AI can collaborate with each other, and they can learn to collaborate with each other. That just opens a new door about how we think about PvE games, how we think about creating a world that is so engaging and so fun to play. So I think the development and progress in AI over the past 10 years, I feel so fortunate and lucky to be here and being able to experience and see what's happening over there and what it means to gaming. And a lot of adoptions, some of the ideas I just mentioned, are happening in the gaming industry pretty widely. Rob, I think another part of the question mentioned was, what do you think about, hey, the gaming industry potentially can facilitate or in gaming help the data and machine learning that's development in general? Gaming is just such a great playground and training ground for AI and machine learning. I'm sure you have been following a lot of the progress for many years and many of the audience as well. Some of the most prominent playground for AI, the games. They could be some of the older games. It could be some ambitious places actually trying some new games like Dota, some of the shooting games as a playground for AI. The games create such a both controlled as well as rich environment for the AI to go learn and for the researchers and developers to observe and tweak and understand what's happening over there. So game creates such a great space for the AI to learn and for the people who are interested in doing research in AI to understand what's going on. I think there are a lot of great progress recently to create kind of a parity of the word in a certain environment. It could be for driving, could even be for some surgical or healthcare use cases. You can create very much a parity environment or virtual world for the AI to tinker on, which is very manageable, very effective learning environment, and very safe compared to really put a car on the streets. So I think there's a lot of progress happening, super exciting. And I think the connection is just going to get really much and much stronger moving forward.
Yeah, loads to unpack there, I have to say. I want to quickly just define a couple terms in case someone out there isn't necessarily a video game fan, although I do suspect that the AI practitioner video game fan Venn diagram has a lot of overlap. But an NPC is a non-playable character, right? So anything that is a bot or an AI, as you said. PvE, player versus the environment. So sort of you're playing against the game itself as opposed to other players in a one-on-one human versus human capacity. But with regards to the NPC, I thought that was so interesting that game AI versus AI, you made a point to differentiate that because a game AI has like a decision tree, whereas a purer form of AI would involve learning. Could you speak a little bit more about the difference there? Is it that a game AI is more finite, or how would you sort of characterize the two?
Yeah, that's a great question, Rob. So if we talk about, hey, a finite state machine or a behavior tree type of AI, they're basically very similar to the very old days of AI. It's a human crafted expert system. Probably it's one way to think about it. All the rules, the logics are there. You can tweak it a little bit to add a little bit stochastic components there to make it a little bit more fun. But still, it's a human crafted system. Today, when we more generally talk about AI, we're talking learning is a huge part. AI is learning either directly from the signals or, for example, reinforcement learning is learning through interacting and try and error in the environment. So they're very different. If you think about moving forward, a lot of researchers and actually a lot of game companies start to think about how do we really embrace the development in the general AI space and create agents or create AI in the game that are learning and very engaging. And instead of have to handcraft every rule, handcraft every probability in the old AI system, we want the AI to learn, to adapt to how the players are consuming it. So I think the distinction was so clear back in the days, and I guess at least today as well for most of the games. But we start to see the development start to blur in the line because more and more game developers, they realize by adopting the new AI technology, by adopting the mindset and technology of making the AI agents to be able to learn, there is so much more richer experience that we can provide from the in-game NPC you just mentioned.
Yeah, that makes sense. Could you give an example of AI in a video game, maybe going beyond the traditional view of game AI that you find truly impressive or that is just sort of like a great leap forward from your point of view?
Yeah, absolutely. So one thing I want to mention is that I think there is always two parts that are developing. And if two parts are in balance, I think that's the perfect case for progression. So one part is we would love to understand what's the awesome use case that a certain technology will be able to unlock. And the other part is we would love to understand if the current progress of technology would actually able to support that type of use case. I think right now, AI is in this phase of finding a match of those two arms. And there are a lot of great progress in the AI technology. And we're still trying to figure out what is the killer app of using those new advanced AI in gaming. Yeah, I'd love to hear what you think, Rob. And I think there's a lot of conversations in the space right now. One of the use cases I want to mention is there is a game developer in China, Tencent Games, and one of their very popular game, it's a mobile game, which is a multiple players, 5 players on each side fighting each other. That game developer, they built an AI based on reinforcement learning and a lot of advanced technologies. And they open up this feature to players to go try to play with those AI to see if you can beat them. And they made it kind of a game mode over there. And the players are really impressed because in the past, if a professional player goes in to play this type of game, no matter how well you handcrafted the AI system, there's just no match to human. It's like, hey, the professional player go there, totally crush all the opponents from AI. But this game is different. This AI is different. The professional esports player coming in, they will have a very competitive experience with this AI. And different skill level players coming in, they can choose to play with different types of skill level of AI in the game. And they can feel really engaging. They don't feel they're playing bots. And when they are playing, they could feel, oh, wow, this is engaging. This is like giving me really great experience and competitiveness that make me sometimes forget I'm playing AI. And sometimes they do remind me because they're just too good, right? So that still happens. And I think that is a really profound example about when you enable this experience with this type of technology, there are some new experience you can deliver to the players. It was just not possible in the past. And for sure, I think the game industry overall, a lot of the friends connections, a lot of folks in the space, having a lot of discussion, thinking about what's a killer app of actually leveraging this technology and making it so meaningful to player experience. It's still an ongoing journey. I think we're in a very good position and getting closer to really figure it out.
Xiaoyang, this has been a fascinating conversation. Thank you for walking us through your company, your background, and all of your takes on AI in the video game space. Awesome conversation. Thanks for doing this with me.
Thank you, Rob. Again, thank you so much for having me. I had a lot of fun.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. Specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.